Good morning, friends. Today we are going to discuss about the rate law and order of reaction. Okay, rate law and order of reaction. Okay, rate law or rate equation. Rate law or rate equation. Already we know that the rate of a chemical reaction depends on concentration of the reactants. That means when concentration of the reactant increases, the reaction rate also increases. The dependence of the reaction rate on concentration can be expressed in terms of an equation which is known as rate law or rate equation. We can consider a general reaction. A moles of A reacts with B moles of B, forms some products. The rate law for this reaction is rate equal to K into molar concentration of A raised to X into molar concentration of B raised to Y. Here K is called rate constant or specific reaction rate. K indicates rate constant of reaction. Rate constant of reaction or specific reaction rate. Then what is meant by rate law or rate equation? Rate law is the mathematical expression which indicates the reaction rate in terms of molar concentration of the reactants, in which each concentration term is raised to some power. Some power X and Y, which may or may not be equal to, this power may or may not be equal to this number of moles, that is A and B, in this balanced chemical equation. Okay, then again, okay, what is meant by rate law? The rate law is the mathematical expression which indicates what? This mathematical expression indicates the reaction rate, okay? The reaction rate can be expressed in terms of molar concentration of the reactants. That means molar concentration of A and molar concentration of B. Molar concentration of the reactants. Rate law is a mathematical expression which indicates the reaction rate in terms of molar concentration of the reactants, which is raised to some power. This concentration term is raised to some power. Here the power is X and Y, the power of the concentration terms X and Y. Some power which may or may not be equal to number of moles in the balanced chemical equation, that is A mole of A and B mole. In the balanced chemical equation. Okay. Here the power of the concentration term is X and Y. The value of X and Y can be determined experimentally only. X and Y, the power X and Y are experimentally determined quantities. Okay, this value of X and Y may or may not be equal to number of moles in the balanced chemical equation. This equation gives us the information that rate of this reaction depends on X moles of A, X moles of the reactant A and Y moles of the reactant B. Okay, on the basis of this equation, okay, I am going to explain order of reaction. Next step is order of reaction.